Dear viewers, in two of our previous videos, we have seen how to calculate probability and cumulative probability for data which is normally distributed and data which is binomially distributed. So normal distribution generally for data which is continuous or variable data follows normal distribution. Sometimes even continuous and variable data can follow non-normal distribution. That's a different discussion. And we have also seen cases of binomial distribution, discrete binary data, data which follows yes, no, pass, fail, good, bad. So we have seen how to calculate probability for these two distributions in two of our previous videos. So I'll share the link of those two videos in the description so that people who have not seen those videos can have a look at it. In those videos, I have clearly explained the basics of probability. What do we call by probability? What do we call by chances of an event occurring, chances of an event not occurring, and what we also call as cumulative probability, that is the combined probability. So all these basics of probability is being already explained in those two videos. So I would request you to kindly uh, listen to those videos to have answers to these basic questions. Now, as the third video, as part of this probability series of videos, we will understand how to calculate cumulative probability for a Poisson distribution. So what do we call as a Poisson distribution? Any data which is discrete count. So what do we mean by discrete count? How many number of a data which is counted and represented as a whole number, cannot follow fractions or decimals. How many people came for shift today? How many transactions you reported defects? So these are all questions where you count and represent the data. It is a counted and represented data. So this kind of data is what we call it as Poisson distribution. And how to calculate probability for Poisson distribution, how to calculate cumulative probability for Poisson distribution, how to do it in Excel, how to do it in Minitab. These are the questions that this video will answer. So first, let's look at it from a case study point of view. What is a case study? The average number of repeat calls in a voice process is 20. On a particular day, there were 25 repeat calls. How serious is the problem? So this is a case study in front of us. So people who have worked in voice process or contact centers will know that customers would expect their query to be resolved in the first attempt. So first call resolution is a very important metric. Sometimes people call it FCR. Sometimes it is people call it as first transaction resolution. So different terminologies with which this is being called, but we generally don't prefer a customer to call us again for a same issue. So if a customer calling us again for a same issue, then it is understood as a problem to the process. And in a voice process, typically out of all the calls they receive, 20 of them will be a repeat call. That means the customer is calling more than once for a particular issue. So in such a kind of a process with a historical average of 20 repeat calls per day, on a given day, there were 25 repeat calls. So the question in front of us is, how serious is this? So in a process with an average of 20, if you get a day with 25 repeat calls, how do you identify or how do you statistically decide whether it is a very serious problem or it is okay, it's a normal day? How do you decide that? And for that, we are going to again calculate probability of getting 25 repeat calls in a process where the average repeat calls will be 20. So friends, I already explained in my previous videos about probability and cumulative probability. Cumulative probability is nothing but combined probability. So in Excel, how do we calculate it? In Excel, we have a formula which is called Poisson distribution. So if you see here, this is the formula. And if I select this formula, it basically asks us to enter three values. Value number one is X. X is nothing but what is the number for which we wanted to calculate this cumulative probability. The second information that we need to enter is the historical average. And the third information is, do you want to calculate probability or you want to calculate cumulative probability? So what does it mean? For an example, let me tell you for an example, I am entering 24 and then I put a comma and then I'm entering my average is 20. And then after that, I can either close this with a 0 or I can close this with a 1. If I close this with a 0, it is called probability. If I close it with a 1, it is called cumulative probability. In this case, if I close this with a 0, what I will get is 0.056, a very low probability. And what is the probability? This is the probability of me getting exactly 24 repeat calls. This is the probability of me getting exactly 24 repeat calls. Why we call it exactly 24? Because this is the actual probability for 24, right? This is the actual probability for 24. But I don't want this. I want to know what is the chances of me getting anywhere from 0 to 24 repeat calls. Then what I do, I enter 1. And now what will happen is this will give me cumulative probability. And now if you see, the chances of me getting anywhere from 0 to 24 repeat calls is 0.843. So again, in my previous videos, I have told if you wanted to find out what are the chances of you getting 25 or greater than 25 repeat calls, what you need to do is you need to subtract the chances of you getting 0 to 24 repeat calls from 1. So reason why we do this is the chances of an event not occurring is nothing but 1 minus the chances of the event occurring. In this case, the chances of me getting 25 or greater than 25 repeat calls will be 1 minus the chances of me getting 0 to 24, cumulative probability of 0 to 24 repeat calls, and that turned out to be 0.15. So what are the chances of me getting 25 repeat calls in any process which on an average get 20 repeat calls? The chances is 0.15. It's not a high probability, but at the same time, it's not a remote probability. It is 0.15. So 0.15 is close to about 1/6 of a probability, right? It's the chances of that occurring is 1 out of 6. That is the chances of that occurring. So yes, there is a cause of concern, but not it's a extremely serious scenario where the process need to be immediately stopped. It requires attention because the probability is less, but not a very low probability. So friends, we have seen how to calculate probability and cumulative probability for a Poisson distribution in Excel. Now we will see how to achieve the same thing using Minitab. So in Minitab here, I write as repeat calls. And what I want to know, I wanted to know cumulative probability of 0 to 24 repeat calls. So I'm entering 24 here. And now I wanted to know cumulative probability for Poisson distribution. That will be in my C10 column. So what I need to do is I need to click on Cal. I need to go to probability distribution. And in probability distribution, I have Poisson distribution. So friends, it's very important that we need to identify the right distribution, right? So continuous data follows normal distribution. Binary data follows binomial distribution, and discrete count data follows Poisson distribution. So I select Poisson distribution. Again, I have two choices. I can go for probability or I can go for cumulative probability. Here I'm going to calculate cumulative probability. What is my historical average? My historical average is 20. My input column is repeat calls. My optional storage column will be cumulative probability for Poisson distribution. Now I click OK. And what I get here is the cumulative probability of me getting 24 or 0 to 24 errors, right? So in the same way, if let's assume if I wanted to know the actual probability and not cumulative probability, I can save my optional storage data in C11. So this is the probability of me getting exactly 24 errors. This is cumulative probability of me getting anywhere from 0 to 24 repeat calls. Now I copy this data, I take this to Excel, I paste it here, you will see this information is the same that we got through our Excel calculation. And again, if I wanted to know what is the probability of me getting 25 or greater than 25 errors, I can say 1 minus this probability. So friends, I have explained how to calculate probability and cumulative probability for Poisson distribution in Excel as well as in Minitab. As I told, I will also share the link of the other two videos. I have explained how to calculate cumulative probability and probability for normal distribution. Same way, how to calculate probability and cumulative probability for binomial distribution. I hope this video was useful. So for more videos on statistical concepts, Lean Six Sigma concepts, how to use Minitab, how to use functions in Excel, please subscribe to our channel. See you in another video. Thank you for watching.